Well, good evening, everyone. It's Thursday evening, and it's time for another Black Forest intro to cross-country webinar. So tonight we're talking about glider flight tracking. So here's where our overall schedule is. So we're not doing too bad. We're got tonight, and then 2 weeks, and then it should be, well, actually, we're starting to see soaring season around here already. So Uh, we'll be off into soaring season here shortly. Again, a couple of, our first kind of standard slides. Presentation is available on the SSA website, on the members website. Here's the instructions on how to get to it. And we need to thank the SSA and Frank Whiteley for hiding in the background and keeping this thing up and running. Our wings folks. Uh, these folks work to make sure that these sessions are eligible for Wings credit. Again, you use your same email address that you use for your Wings, and everything happens automatically. One of the things that the FAA has agreed is these online sessions. The online session itself is eligible for credit. However, you must be in the webinar for either the full webinar or at least an hour to receive credit. We have some of our instructors hiding in the background, so if you've got questions, you can type them. They'll try to answer them as we go along. If they're more general question, then we have a Q&A session at the end, and they'll bring them up then. So off into glider flight tracking. Some folks that we need to acknowledge, Pedja kind of started this thing using smartphones. His mechanism isn't in place anymore. Uh, Dave Chapins with Arizona Soaring has done a bunch of work, including cross-connecting Spot and InReach and ADSB out over into the OGN system. And plus, he worked with deployment of OGN ground stations across the SSA. And then John Gillis is our OGN expert in our club, and we have 6 ground stations. 3 of them are operational right now. One is seasonal, way down in the southern end of the state. We're waiting for the snow to melt down there, and 2 of them are down a little bit for maintenance. So Pedge's mechanism is no longer operational. It's possible that the forwarding mechanism from Spot, InReach, and ADSB may not be operational. It's not clear what's happening with that right now. So our purpose this evening is to examine flight tracking options. When we're working with this, it all starts with safety. One of the problems with using existing aircraft's mechanisms is gliders are seldom on FAA flight plans. Gliders seldom carry ELTs. And in reality, until the advent of the 406 megahertz ELTs with built-in GPS locators, ELTs were not really matching. What they were expecting didn't match our flight profiles. One of the things that we run into is that gliders are often away from their home airport for hours at a time. I'm not sure how many people truly realize it, but every glider pilot probably does, and that is we cover hundreds of miles. And at least for our club, our members often head off in very different directions. Our club doesn't really run like here's today's task. It's, if there's a group that's going to fly together, they'll discuss their task and weather. But for the most part, everybody's kind of heading out on their own. So one of the nice things about a glider tracking mechanism is it provides a status on the locations of our members during the day. And then they can help reduce the search area if assistance is needed. For instance, somebody lands out. So in the tracking, it provides a report of a glider position, so lat long, and some of the systems will do altitude. They almost all provide some kind of ability to send a message. What it does not provide is it does not provide automatic emergency locator transmitter or ELT capabilities. Our tracking architecture in the grand old days, we got our position data by looking outside, and then in the glider, the pilot does the positioning processing. He looks outside and says, "Oh, that's where I am," and then he clicks on the mic and says something like Yankee 7 over Fremont headed south. And that's on 122.3 for our frequency or for our channel. The terrestrial processing for that, somebody hears the radio call, they might tell somebody, and they might make a note somewhere. So all kinds of opportunities to lose data somewhere. In our more modern system, we've got GPS satellites, so we're getting our position data in the glider. One of the things everybody needs to remember is it takes at least 4 satellites to get an unambiguous 3D position. So we have the data coming down off of a RF link from the GPS satellites. The glider determines the position, and then it sends position reports. And when I say single units, we can have like a farm where the GPS and the reporting are all housed in one box, or it could be split across multiple units where we have a GPS feeding another device, for instance, your navigator device, CU navigator device, and then sends it out. Or then you're linked also with maybe your hotspotting on your cell phone, that kind of thing. So it comes down on some RF link. There's terrestrial processing associated with it to process and distribute the position information. That goes out in any more over across the internet. And then, you have a local display. Like in our club, we have a big TV monitor that's hooked to a computer and has a display up in our clubhouse. Now, when we're looking at this, we have a lot more stuff available to us. So we have all of the GPS stuff that I showed on the previous slide, but now this RF link that's coming down, or that's taking it from the glider and getting it out to where it needs to go. We have SPOT, which is a satellite constellation. That's Global Star Satellite Constellation. InReach uses the Iridium satellite constellation. FLARM and the soft RF devices are transmitting on 915 megahertz in the US to an OGN ground station. We can have smartphones using local cell towers, getting the data down. And then we have the FAA, which is the 1090 megahertz transmission that goes to the ground-based transceivers or goes to the radar system. So these are the mechanisms that we're going to be talking about this evening. In the terrestrial processing, so we've got what's supporting our cell phones, our smartphone and the tablets, SPOT, InReach, OGN, and the FAA. So they come out to their various distribution channels. One of the things that CU Navigator is doing is it's taking the data from the tablet or from your smartphone running CU Navigator and forwarding it. It goes out across the cell phone system into the OGN system, so it's forwarding the data if you have that turned on, and I'll talk about that more later. So OGN is giving us a distribution to the soaring community. The others are going out to their server or their distribution mechanisms. Now I talked about the thing where we had the forwarding from SPOT and InReach and ADS-B out. Those, I've got them dashed because one of the things that I'm hearing right now is that it's still functioning, but it may not be functioning for much longer. And I don't know any of the details behind that. So our enabling technology for this, the global positioning system. So this allows the determination of the glider's position with the receiver on board the aircraft. And now we've got a airborne communication infrastructure. So this allows the glider to connect to the trafficking infrastructure on the ground. Now, some of the things that we need to be aware of, there are issues associated with this. So we have low power transmitters. We're working on shared frequency. For instance, in the United States, the FLARM operates on a band called the Industrial, Scientific, and Manufacturing, or you'll hear it abbreviated ISM band. And everybody, since it's shared, they have to put up with interference. Now, one of the nice things that FLARM does is it works spread spectrum, so that reduces the incidence of interference. But still, we're working on shared frequencies. We're prone to lost messages. There's no guarantee of delivery of any specific message, whether you're talking satellite or you're talking FLARM or even ADS-B, there can be lost transmissions. The One of the things we're prone to is configuration errors on the devices or in our ground processing. And then the last one is the tracking display is not real time. So it is somewhere between seconds to multiple minutes, 10, 15 minutes behind the actual location. So it's not real time, but it's probably close enough for what we're trying to do for the things that I mentioned. We have a couple of different types of trackers. We have satellite-based communication infrastructure, and then we have a ground-based communications infrastructure. With one exception, the tracking systems available to the soaring community is taking advantage of equipment that's built for other purposes. So let's take a look at the airborne communication for the satellite-based system. There are two major satellite systems, Iridium. It's basically a cell phone system in the sky. The Garmin inReach products use Iridium. Globalstar is another satellite system. It uses a slightly different approach. We'll talk more in detail. Its Spot uses and is owned by Globalstar. Interesting little thing was just announced within the last week. It looks like Amazon's going to acquire Globalstar and all of its assets, and so that they can operate both the mid-altitude satellites that the current system, Globalstar system, is, and integrate that with the lower orbit satellites that Amazon wants to play with. So, Iridium, it's a polar orbiter. So the satellites go over both poles. So it's got a true north-south orbit. It has the ability to communicate across the orbits and within, they call that cross plane. And then it also has the ability to communicate in plane. That means that it can have fewer ground stations. There is processing that happens to the signals on orbit. Since these satellites are moving, you see this is a representation of about 10 minutes. The distortion towards the pole for those visibility circles is because we're looking at a Mercator projection. But notice that there's usually multiple birds having a view of a location. And, if you look up over the United States over here, you can see overlapping areas. And you can see that, the satellite covers this, they've got satellites moving at about 10 minutes within view. So there's not much delay involved. Globalstar uses an inclined orbit, so it doesn't move its satellites over the poles. It's up at about 870 miles above the surface of the Earth. They're inclined at 52 degrees. Like I said, no polar coverage, but it does provide good coverage from 70 degrees north to 70 degrees south. These satellites don't talk to each other. These talk to the ground. So this is a bent pipe system with no processing on orbit. So it requires the satellite to be able to see both the originator of the signal, so it has to be able to see the glider, and it has to be able to see its ground station. Now, the locations, um, this is a couple of years old, but it's no worse today than it was. In fact, it's better now than it was when this one, but we're interested in, I'm assuming majority of the folks that are on tonight are in the United States. Notice that we've got uh, the blue is SOS and two-way message coverage, and the blue basically indicates that we've got full coverage all the time. In the satellite-based infrastructure, I'm using the spot or the global star slide as the thing to illustrate it. You've got the satellite system, so you have the spots that goes up to the satellite, comes down to an antenna, then goes to a central processing location, or maybe multiple processing locations, and then it's distributed out uh, through the website or perhaps onto a cell phone if you're sending a message. There is an emergency response center worldwide for the SOS message. You can have it send emails out from this processing mechanism. If you have a system in which you can receive messages in your glider, then it's going to come in through this ground processing infrastructure, go out to an antenna and up to the satellite, and then down to the device in your aircraft. So here's the tracker, gets over to the ground infrastructure for processing, and then is put out for dissemination. And then here's what the trackers look like. So the one on the left is a small Garmin. The one in the middle is the original Spot and the Spot Generation 3. And then the one on the right is another device that's got two-way communication. Nice thing about the Garmin is it can pair with a cell phone, so you can send text messages and that kind of thing. Spot does have one receiver that is basically a cell phone or satellite phone. When we're looking at the trackers, okay, both systems are designed primarily for surface activities. In-flight usage wasn't necessarily a design consideration, but it does work for us. The data message has a default rate. It might be configurable. So like on Spot, something like every 10, 20 minutes. The later versions of both Spot and Garmin, you can get position data down to like 2.5 minute intervals. Of course, faster costs money or costs more money. Some of the devices actually will include altitude. And this is just a quick summary. So for Spot, for the simple devices, you get 3 message types. You have 2 of them that are that you can specify what's in the message that goes out. They're pre-canned. You set them up before you take off. And then there's one that's fixed. That's the emergency. That's the one that's marked SOS on the device. And that sends a specific message to a centralized dispatch center. Basically, they're working with 48 satellites. The device is often between $145 and $250. But there's always discounts. The basic tracking service, the way you have to read the websites carefully, but basically you're going to be in around 175 a year for a 12-month subscription. I use mine for more than the glider, so I buy it by the year. You could buy it by the month. Uh, Position data in Garmin, again, It's nominally about 10 to 20 minutes, but they can have it, you can get it much faster. You have message types, so you can send SMS messages, so text messages plus the emergency message. They're running 76 operational satellites, 66 of them are operational, and the others are spares on orbit. The devices are more expensive, but they give greater capability than the Spot device. And basically, the tracking service is somewhere between $15 and $50 a month, depending on, you know, what kind of options you want to have on your service. That's the satellite-based system. Now we're talking about ground-based mechanisms. So this is the state of Colorado and showing cell towers. The blue dots with numbers in it are saying that, you know, like for instance, this one up here has a 4 that says that there's actually 4 receiving mechanisms right there. The red X doesn't mean something bad. It just means that's a single tower. The density on these things is absolutely phenomenal. For instance, in the Denver area, there's something like 1,800 uh, cell sites that you're communicating with. So the website, oh, all the way, by the way, all the links I've checked today, and so they're all good. This is a third-party service, and you have to kind of search around on the site to get the map to where you can see this information. If I zoom it in, like on the area around our airport, so the I pinned where the airport approximately is. So we've got cell service antennas roughly 5 miles to the east of us, some others over here, 8, 9 miles, 10 miles out. One of the things is, for instance, our ground elevation at our airport location is 7,000 feet above sea level. These antenna over here are actually in a creek bed below the top of the or below the surface of the plateau that our airport's on. So in some cases, our cell service is kind of sketchy, but once we're in the air, it works pretty well. Now, all of these images, these are showing cell phone towers or smartphone towers or personal communication device towers that are unique. This is not talking about antenna arrays that you see on a church or a school or something like that. They're out there all over the place as well. So these are just specifically towers. So the way this one works, we've got our cell phone in the aircraft. Almost all cell phones are now using GPS satellite signals for the position information. Our cell phones are considered personal communication devices, so they're not cell phones. The shift from to digital signaling rather than analog signaling alleviated a lot of the airborne interference problems. And so, yeah, you can use it in the plane. So you're going to go from your aircraft into the cell network, and then from there to a dedicated server connected. Its dissemination is going to go out to the uh, internet, and we're going to get, hold on a second. I clicked too quickly. We're going to get out onto the internet and then back to however it's distributed. So I'm not saying specifically who because we'll talk about that here in a little bit. The smartphone tracking apps, the specific apps that came out that were using an app, like Glide Track on the Apple phones, those guys have disappeared over the years. So what you see now is, for instance, on Navigator or Navigator, the CU people in the Navigator software have a mechanism that allows you to report your position through the cell network. Um, I don't know if the OGN layer is on the free portion, but I do know it's available on the annual fee. The same thing applies for the Android devices. So you turn on the OGN layer in the layers display, and I'll show that a little bit later. The other thing that has grown up over the last few years is the Open Glider Network, and this is its ground-based infrastructure. The objective of the Open Glider Network is to create and maintain a unified tracking platform for gliders, drones, and other aircraft. Okay, that objective is a direct quote from their website. For us, the devices are FLARMs, and I'm including the soft RF devices that we talked about when we were talking about uh, collision avoidance technologies. And then there is a specific OGN tracker device. Then we have the OGN specific ground receiver network. Now, very important, if you're using a non-FLARM licensed device, so a soft RF device, chances are you can choose the protocol that it's using to communicate. If you're also using your soft RF device for FLARM in-flight visibility, do not use the OGN tracking protocol, the OGN TP. FLARM devices do not process that protocol, and if you configure your device to use it, FLARM will not see you. You will see FLARM, but FLARMs will not see you. So be sure you know what you're configuring when you're configuring your device if you're using something like the soft RF devices. The overall OGN architecture. So we've got our gliders up here. This one has a FLARM in it of some flavor. This one has an OGN tracker. So remember, FLARMs communicate direct to other FLARMs, whether they're on aircraft or whether they're in UAVs, whatever. If it's got a FLARM, you're doing bidirectional. Plus, the FLARM ground stations are receiving, and from there we come down to the antenna. It's got to be a line of sight, and so this is one of the things that the SSA's program from a couple of years back of getting OGN stations out, and we'll take a look at more in detail of that in a couple of minutes. So then we come through the receivers. The receivers connect across the network to the OGN servers where the processing happens. And then from there, you have the dissemination out to the OGN network or, a search and rescue, flight radar, or some other custom client application. Okay. Across the United States, this one is a little bit dated, but you can see this is that's showing traffic. The traffic it's showing is already the traffic for 2026. So you can see the areas where it looks like there are receivers. You can see where they had the contest down in Florida. And this was not quite showing so much down at the contest in South Carolina right now. But where the red circles are, like right here, that's the sites. You can go and see the sites by clicking on, when you have the presentation, by clicking on the on this logo. That's a link. Now, for instance, between us running from southern Wyoming to central New Mexico, we have 11 OGN sites running down through here, which means we've actually got pretty good coverage across that whole area. So there's one up in Cheyenne, Wyoming, one in Owl Canyon, so that's Colorado Soaring Society. A few miles east of the Boulder Airport, that's Boulder Soaring Society. We have one at Kelly for the Black Forest Soaring Society. And then we have 5 others that are maintained by us, one in Pueblo, one in Canyon City, Salida, Buena Vista, and La Veta. So we get pretty good coverage back into the mountains. It's pretty nice to have. And then we come back around to the FAA. We've talked about this in the collision avoidance. So we have the aircraft. In this case, what we're talking about is ADS-B out. So that's our tracker. The processing happens in the control station for the FAA, and then the dissemination is out through the FAA's channels. When we're looking at the map displays, for instance, spot, since you've only got something about every 10 minutes or so, or maybe even longer, maybe 20 minutes, the straight lines are between the fixes. So that's not the path that the glider flew. That's just a straight line between fixes. The numbers next to a fix indicates the number of fixes at that location. So right here, there's 4 fixes. So very likely was thermaling. Okay. The other mechanisms that we have available to us, the glider, open glider, these are all coming through the open glider network mechanism. So glider, this is glider net. Most of the time when you pop this up, I've never taken the time to figure out how to make it come up at my location. So I zoom out and then zoom back in so that I can see it. And this is just a second. Let me show you what I'm looking at. Well, I was going to. Okay. Anyway, these sites will give you the ability to get to different displays. Glide and Seek is kind of nice. Glider, this is the OGN network's display, and it's not real. It's obvious when you see the tracks where the sites are. Glide and Seek is nice because it will show you the receiver locations. I have a line through glider radar because their site seems to be having a problem. It doesn't mean that it's offline, but it does seem to be having a problem. And so Pure Track, this is Tim Bromhead's in New Zealand is an excellent resource for this. Uh, and for instance, the Region 5 in South Carolina is managing their contract using his software. And it's really nice. One of the things that I found that I like with it is it will also show other traffic. His mechanism seems to be sucking in from a number of different sources, and so he seems to have aircraft that not don't necessarily show up. For instance, we have one gentleman in our club that is using a different mechanism. I'm not sure what it is, but he's using a different mechanism for reporting his position. He doesn't show up on OGN, but he does show up on the Pure Track. And so I really like that. And then we have WeGlide and WeGlide Live. Now the one of the things with the WeGlide Live is it's only tracking gliders that are registered in the OGN database. So it's not picking up just somebody that is not in the OGN database but has a FLARM. It's not tracking those aircraft if they're not in the OGN database. So my tracker configuration, I carry a spot tracker, and then I have the FLARM, which goes to OGN. I have Navigator on an Android tablet tethered to a smartphone. So if I turn on the OGN layer, that's reporting my position. And then I have ADS-B out in my glider. So when we're talking about using these things, what's going to have to happen is you've got the tracker, the processing, and then the dissemination. And so in the tracker, you've got to configure your tracker for the user, for the aircraft, and the messages that you want sent. For the processing, you're going to have a user profile with whoever's providing the service for you. So to identify your user, your purpose, like glider or hiking, biking, kayaking, you're doing a road trip, also configuring your messages and dissemination, which might be in the user profile. But what channel are you going to use? Is it going out as an email? Is it going out to a website? And what are the messages that are going to be distributed? Some of these, an awful lot of this can turn out to be configured in the processing node in your user profile right here. Okay, but you'll still need information about your tracker so that it can link your tracker to your account and that kind of thing. The other thing that you need to do is you need to know how to use your tracker. Now, I'm showing a first generation Spot just specifically because it was a royal pain. So the on off, you held it, you hold this button for right here for 4 to 6 seconds, and then the LED right here will start to flash green. To turn it off, you hold this until the LED goes off, and again, that'll be about 4 to 6 seconds. If you want to send your standard OK message, because you have an OK message, a message that says, I could use some help, and then you have the emergency message. If you want to send your OK message, you just press it and release, and the LED right here will start flashing, and it will, once the message has gone out, then it will quit flashing. The mistake that so many people made is they thought they just turned on their tracking, and they didn't. To turn the tracking on, you press, excuse me, you press the OK button for 4 to 6 seconds, and then the LED above starts flashing. Okay. And it generally, not necessarily always, but it generally flashes in sync with the power LED. And then to turn the tracking off, you press and hold the OK button for 4 to 6 seconds, and then it will go red, and that tells you that it's out of the tracking mode. And what we used to see very often is people would come up and press this real quickly, thinking they'd turn their tracking on, and all they did is they sent their I'm okay message. The help button over here, this sends your I could use assistance message. I have mine set up for I've landed out. And it sends my location, and then the message that I have canned for it is, my cell phone number and who to call, and maybe some phone numbers for them to call. And when you press that, the LED up there will flash until the message has gone out. The 911 message, this is the emergency message, and this has a rim around it to make it a little more difficult to accidentally press it. You press it and hold it for 4 to 6 seconds, and that's sending a message with your position to the emergency dispatch center. And that goes to a single location, and then based on what your location is in the message, then they will attempt to contact emergency services that are most appropriate for the location that you're in. So when you're setting up your tracker, some of the things you have to work with. So we're talking about Navigator, Flarm, and ADSB out. So what you want is, if possible, you want to use the same address for all the devices in your glider. Okay, so what you're going to do is you're going to set it up to the ICAO address. To convert your ICAO, your IN number to an ICAO address, here's the link for that. And you just enter the numbers, or the 4, 5, or six digits for you don't enter the N, and then it will give you the IKO address in hex, the six digits in hex. You write that down and you've got it. The other thing that you want to do is you want to set up an OGN account with the OGN device database. And so this link works. You create your account, you register your glider, and you use your IKO address for your glider. So the whole idea here is then that all of the, if somebody is doing data fusion and pulling this stuff together, then it's all using the same ID, and then they use a priority as to which one of the IDs that they use. Okay. But if you were coming down with three separate IDs, you had one for your FLARM, one in Navigator, and you had your ADSB out, and they all three hit on the same spot, then how do you know which one is it three aircraft? Is it one aircraft? It helps to get rid of the confusion if you just use your IKO address for your identifier. It was interesting when Navigator came out because Navigator assigned a unique ID to each software. No, not each software. Each device the software was running in. They eventually came back around and got it to where you could configure this. So what I'm going to walk you through here is the steps for that. So in my case, I've got several gliders in my database. And so I have a thing here. This indicates that I can go to a list and select from my list. If I didn't have that, I'll show you how to get there in a minute if I've only got the one. So I select that and we go to the screen. And so I'm going to switch it over from my Ventus to, I'm going to add the K21, our Club's K21, and notice the N number 314 Kilo Sierra. And then we're going to go back, since I've now got it selected, we're going to go back to the previous page and select this glider. Now, if you've only got one glider, this is where you'll start. Okay. And we're going to go edit that glider. So here it is. And notice that I don't have a FLARM ID set right here. So we're going to edit. And now we're on the edit screen. And there's where we're going to go. And that's the identifier associated with 314 Kilo Sierra, at which point you back out and back out again. And now we're out here. And now we're going to go over and look at the flight screen. And so here's the flight screen, and this is your layer control. And from your layer control, I have FLARM turned on because I like to see the FLARM targets, and I'm connected between my FLARM and my navigator. And now I'm going to turn on the OGN layer so you can see the OGN is on. And now all you do is you just tap outside of the white box, and that'll take you back. Now, one of the things that happens is once you've got that turned on, if you've got the OGN layer on, every time you turn on Navigator, so if you've got it on your cell phone and you have it active, then you're sending a position. That's where you see the ground tracks that run into the Class B airspace because somebody didn't turn it completely off on their cell phone and they're driving through the area. So what you do there is you scroll down on the page, hit the sleep button, and tell it, yeah, you want it to go to sleep, and that will put it in the sleep mode, which that starts the shutdown sequence. And Navigator will remain in the background apps list, but it's no longer consuming power. It's not using the GPS, and it's not connecting to the internal or external devices or channels in this mode. So you're not sending out your position. When we talk about FLARM, everybody should be reasonably aware of this, but let's step through it. There is a magic file on your USB stick for your FLARM called flarmconfig.txt. It resides at the top level of the memory structure of the stick. Use a text editor, not a word processor. Do not edit on an Apple machine because an Apple machine, the software adds additional data and the FLARM then won't be able to read the file. You're stuck doing this on Linux or Windows and using a text editor. You want to search the file for ID. Now, there may be multiple hits for ID because of other things that are happening, but here's the line you want to look for. So $PFL AC, comma S, comma ID, comma, and then there's a sequence of digits. That can either be a random value that's set at each boot up. You know, that's one of the things that you can set in your FLARM configuration. It can be 6 digits hex. That's an IKO, your IKO value. It can be all Fs, which tells the FLARM to use the radio's factory radio ID number, and the default ID number will look something like this, DF00A5. The DF is what indicates that it's the FLARM radio. Now you want to edit the value for your IKO address. So in our example, I'm editing it to A3569 Fox. And one of the things that you save it and then you plug that in next time you boot it and it will set that up in your FLARM. Okay, this is different than using it for Navigator because the FLARM is normally mounted directly to the aircraft. If you've got a portable FLARM that you're moving between aircraft, then you have to play this game for each aircraft, at which point I would have about, if I had 3 gliders with a portable, I would have 3 versions of the flarmconfig.txt with something in the file name that let me know which airplane has this ID. If you ever stick somebody else's FLARM USB stick in your device to update your software, if it has a flarmconfig.txt file at the top level, it's going to screw up your settings, especially your FLARM radio ID. Okay. So be very careful about sticking somebody else's FLARM USB stick into your device because, like I say, if it's got a config file on it, then it's going to configure it to match that person's device. So how does our club use flight tracking? The if you hit the land out button, the help button, and the message with its location is sent and displayed in info, it gets if they've got the info display up, they can click on it and see your indicator and then see the data that says, here I am. By the way, when you send a crew out on a retrieve, use the map to send out the crew and make sure they have a cell phone so the pilot and the retrieve crew can talk if possible. And recognize that not all navigation devices use the same representation for lat long, and the error can be significant. Um, I did a retrieve out of Logan for someone one time and took a wrong turn because I was navigating with my iPhone and they gave me the spot information, and so I ended up making a wrong turn. And fortunately, we managed to talk to each other, and he was able to guide me back to him. The biggest thing, I mean, it's nice to be able to see people, and we keep it up and running on a display in our club. But the really nice thing is that as we're getting later in the afternoon and we start going, we've only got two or three people, or maybe only one or two people out. Where are they? How does it look like they're doing? Does it look like they've they're dug down into a hole trying to climb out, or they've got an easy final glide back? But it makes it easier, on who all's going to stay and be sure that they've got help when they get back to the airport, or do we need to start looking and getting a retrieve ready to go? The other one is that it's great for outreach because if you've got visitors in your club, you can say, "Oh, this is where Fred is. Look at what we can do." Okay, so the flight tracking systems. So I've got the system over here. What kind of device? What's the communication infrastructure? The data API. So where do you go to get the data? And where do we put, what are we getting it from the for display? I have it lined out for the spot in, reach, and ADS-B out. Like I said, it's my understanding that that's not necessarily going to be available, but last I heard, it still was. So I don't want to say it's not there. When we come back around on this, it's safety. Where are our people? Late in the day, does it look like they can get home? Do we need to prep for a retrieve, or do we just need to be here to hand them something cold to drink and help them get their plane off the runway? The other one is fun. Where is everybody? And outreach, especially when we have visitors, look where they are, look at what we can do. So, questions?
Sorry, Dave. No questions, believe it or not. We had one earlier that was just about using InReach for or Spot for badges and records, but I answered that for them. So, other than that, we do not have any questions tonight.
All righty. Well, we're right at an hour, so we checked all the boxes. Next time, May 7th, we'll be talking about the online soaring contest in WeGlide. It sounds like I'm going to have to rename that. It looks like as of last Friday or Saturday, the online soaring contest has sailed west. So we'll have to look at what we have available for doing our post-flight bragging. Y'all have a good one, and we'll see you in 2 weeks.